Hello students, today I talk about the exponential growth. Sometimes the differential equation is the exponential growth in real world. This occurs when the rate of change of fx is proportional to the current amount. To figure out this concept, let's solve this problem with me. Okay, look at the problem exponential growth. Before starting problems, let's solve this concept. Okay. Look at the exponential growth. The rate of change of y equal ft is proportional to the amount of present. In other words, this means dy over dt. Be proportional to, we need constant k and amount of present y. So I can rewrite dy over dt equal k times y. This formula tells us this is exponential growth form. To solve this equation, let's apply separable method dy of dt. Okay. Let's prove this process. Dy over dt, k times y. Yeah. This is my start point. This is my goal. Y equals c times e to the power of k times t. So the tool is the separable method. First, separate these variables respectively like this. 1 over y dy k times dt. Apply integral on both sides. Then ln y plus c1 kt plus c2. ln y equal k times t c2 minus c1. This is just c. So ln y equal k times t plus c. So kt plus c, this is e to the power of t times k times t times e to the power of c. It is just c. So what? So y equals c times e to the power of k times t. This is my goal. I prove this. This process is important to solve these problems related to exponential growth. So keep in mind this process and apply this in the problem. Okay, today I solved the problem number 3, number 4, number 9, number 10. Look at the problem number 3. Bacteria is a certain culture increases at a rate proportional to the number present. If a number of bacteria doubles in 4 hours, how many hours will the number of bacteria triple? Okay. Yeah, looking at the statements, bacteria increases. In other words, this is dy over dt. A rate proportional to, we need constant k. The number present, it is y. So we can rewrite like this, dy over dt equal k times y. Let's check another assumption. Bacteria doubles in 4 hours. This is T equal 4. Bacteria is, 2 times Y0. Oh, there is hidden assumption. Y0 is initial amount. That is T equals 0. Yeah. In how many hours? It is my goal. This is T. When bacteria triple, 3 times Y0. Okay, this is my goal. Let's use these assumptions. Yeah, this is starting point, dy over dt. This is k times y. Okay. Let's apply the separable method by separating these variables like this, dy, k times dt. Okay. Apply integral on both sides, ln plus c1, kt plus c2, ln y equal kt plus c2 minus c1. This is just c because c is undecided. Ln y equal k times t plus c. So y equal e to the power of k times t plus c. Separate like this. This is c. So c times e to the power of k times t. Yeah. This is the function of growth if exponential growth. Let's use this assumption, first assumption. Yeah. This is first assumption. This is second assumption. Okay. Plug in this value. Y0. This is c times e to the power of 0. This is 1. So c equal y0. Plug in this value. Therefore, y equal y0 times e to the power of k times t. Let's use the second assumption. Plug in this value, 2 times y0, e to the power of 4k. Divide by y0 on both sides. So 2 equal e to the power of 4 times k. Apply ln. This is fold down exponential. Ln 2 equal 4 times k. Ln this is 1. So 4 times k equal ln 2. K equal ln 2 over 4. Plug in this value again. This here. So the final equation is y equal y0 e to the power of ln 2 over 4 times k. Okay. My goal is 3 times y0 where t question. So, sorry. This is t. Okay, sorry. Because k equal ln 2 over 4. Sorry. Plug in this value, 3 times y0, 3 times y0, y0 times e to the power of ln 2 over 4 times t. Divide by y0 on both sides. So 3 equal e to the power of ln 2 over 4 times t. Apply ln on both sides like this. Fold down exponential. Ln 3 equal ln 2 over 4 times t ln e. This is 1. So t equal 4 times ln 3 over ln 2. Yeah, this is final answer. Okay. Look at the problem number 4. Oh, yeah. The rate of population of fungus is given by differential equation y, where yt is measured in grams and t is measured in days. The weight of the fungus population increases according to the equation dy over dt equal k times t, where k is a constant. At time t equals 0, the weight of the fungus population is 140 grams and is increasing at the rate of 28 grams per day. Which of the following is an expression for yt? Okay. This is exponential growth. Yeah. So let's check out assumption t equals 0. Then fungus population y equal 140 and increase at the rate. This is velocity. So dy equal dt equal 28. This is my starting point, but starting solving, before starting this process, plug in this two value, to find k. Okay, so plug in 28 equal k times 140. So k equal 28 over 140. So 1 over 5, plug in again. So dy over dt equal 1 over 5y. Okay, let's start. Separate variables like this. 1 over y dy, 1 over 5 dt. Apply integral on both sides like this. Ln y plus c1, 1 over 5 t plus c2. So ln y equal 1 over 5 t plus c2 minus c1. This is just c. So ln y 1 over 5 t plus c. Y equal e to the power of 1 over 5 t plus c. Separate 1 over 5 t e to the power of c. It is just c. So c times e to the power of 1 over 5 t. This is y. To find constant c, let's use this assumption again. So this is 140 c times e to the power of t equals 0. So 1 over 5, 0. This is e to the power of 0. This is 1. So c equal 140. Plug in this value in this equation. Therefore, y equal 140 e to the power of 1 over 5 t. Yeah. So the answer is P. Okay. Look at the problem number 9. A dose of 500 milligrams of injection is administered to a patient. The amount of injection in milligrams in a person's bloodstream at time t in hours is given by AT. The rate at which of the injection leaves the bloodstream can be modeled by the differential equation dA over dt equal kt, where k is a constant. Which of the following could be expression for AT? Oh, this is hint. Okay, let's check. Assumption. Yeah, this is initial point t equals 0 because this patient has the already already injection. So the dose what this is a unknown a 500. Okay, let's start dt Ka. Separate this variable respectively, 1 over a dA, k dt. Integral apply on both sides, ln a plus c1, kt plus c2. ln a equal kt plus c2 minus c1. This is just c, so ln a kt plus c. A equal e to the power of k2 plus c. Separate e to the power of kt, e to the power of c. This is just c. So I can rewrite a equal e to the power of kt times c. Okay, let's find the constant c by using the initial condition. So plug in this value instead of a and t. So 500 e to the power of 0 times c. So c equals 500. Plug in this value again, the above equation. A equals 500 e to the power of kt. Yeah. But there is another assumption. So, but you check out this expression could be an expression for AT. So it's okay. You find similar answer compared to final result. So the answer is A because of could be an expression. Okay. Look at the problem number 10. During optimal conditions, the rate of change of population over a certain virus is proportional to the population. T in hours at time t equals 0 hours, the population 500. At time t equals 6 hours, the population is 1000. At what time t is the population 800? Okay. This means that this is dy over dt. This is k. This is y. So combining this word, I can write like this: dy over dt equal k times y. It is exponential growth. Okay. Second assumption is t equals 0, the population y equal 500. Yeah, third assumption is t equal 6, y equal 1000. Lastly, this is my goal. T equal question where population 800. Okay. Let's solve this differential equation by using the separable method. Separate like this, kt. Okay. Integral on both sides, ln y plus c1, kt plus c2. ln y equal kt plus c2 minus c1. This is just c. ln y equal kt plus c. Y equal e to the power of kt plus c. E to the power of kt times e to the power of c. Oh, yeah, I'm sorry. It is the c. So y equals c times e to the power of k times t. Okay. Let's find c, k by using these two assumptions. Okay. Plug in this very first value, t equals 0, y equals 500. So 500, c times e to the power of 0. Okay, this is 1, c equals 500. Okay, plug in this value of our equation. So y equals 500 e to the power of k times t. Okay, let's find constant k. Okay, by using the second assumption, plug in this value 1,500 times e to the power of 6k. Okay, divide by 500 and apply ln on both sides to fall down exponential like this. So ln 2 equal 6 times k ln e. This is 1. So 6 times k equal ln 2. K equal ln 2 over 6. Okay, plug in this value again. Therefore, y equal 500 e to the power of ln 2 over 6 t. Okay, let's check my goal. This is my goal. I should find the time where y equal 800. So plug in this value to find the time t. 800 equal 500 times e to the power of ln 2 over 6 times t. Divide by 100 and divide by 5 on both sides like this. E to the power of ln 2 over 6 times t. To find t, apply ln on both sides like this. Ln e to the power of ln 2 over 6 times t. Fall down this exponential by using the ln property. Ln 8 over 5, ln 2 over 6 times t, ln e. This is 1. So ln 8 over 5 equal ln 2 over 6 times t. T equal ln 8 over 5. 6 times ln 8 over 5 ln 2. This is answer. Oh, there is similar answer. This is 6 ln 8 over 5 ln 2. Oh, same. So the answer is E. Is it okay? Okay. Thank you for listening. I'm rooting for you. Good luck. Have a good day. Bye-bye.